Integration? All right, let's do one with integration. I think that's the one that you're least familiar with. So I think that probably sounds like a pretty good option. Okay, so it says that the angular acceleration of a wheel is given by so they say that alpha is given as 6 times t to the 4th minus 4 times t squared. With alpha in radians per second squared and t is in seconds, so SI units. Which is funny because radians aren't a unit, but we consider them to be kind of like SI type of things. So, you know, it says at t equals 0, the wheel has an angular velocity of +2 radians per second and an angular position of +1 radians. So this is our condition. So at t equals 0, then our initial angular velocity is +2 radians per second, and the initial angular position was +1 radian. Okay, so these are going to do the integration constants. Those will be our conditions to set and solve for the constants. Okay. And so what you have to recognize is that A is not constant. So we don't really get the standard kinematics. Well, alpha is not constant. The angular acceleration is not constant. So no standard kinematics. Okay. And so what we can do, though, is we can get that since the acceleration is the time derivative of the angular velocity, since alpha is d omega dt, then we can go in and find that omega is the integral of alpha dt. So we can plug in our values for alpha. And so this is, integral of 6t to the 4th minus 4t squared integrated dt. I'm going to do the indefinite integral, then pick up the integration constant, and then use the condition to solve for the constant. And so then our omega, so we'll increase the power by 1 and then divide. So 4 goes to 5, so this is 6 divided by 5, t to the 5th. And then we'll increase by 1 goes to 3, so this is 4 divided by 3 times t cubed plus some constant of integration. Okay, and now what we can do is we can go in and set our condition. So then at t equals 0, then our omega, the initial omega, will be this +2 radians per second. Okay. And so that'll be +2 radians per second is at t equals 0, this is 0. T equals 0, this is 0. And so what we get is that is the integration constant. And so then we now have omega as a function of time. The angular velocity as a function of time is going to be this 6 divided by 5 t to the 5th minus 4 divided by 3 t cubed plus 2 radians per second. So there's our omega value. Okay, and then we could do things like evaluate this at other times, or whatever they might ask. I think they only asked us to determine the expression for the angular velocity and the angular position as functions of time. So this answers the first part of the question. And then to get the next part, then what we do is we would go in and state that our omega is the time derivative of the angular position. So the angular velocity is the derivative of the angular position. And so therefore, our angular position is this integral of omega dt. We're going to plug this in for the omega. So we're integrating our 6 divided by 5 times t to the 5th minus 4 divided by 3 times t cubed plus 2 with respect to time. And so again, be careful not to take a derivative. Super easy to get those mixed up. Increase by 1 becomes 6. Divide by 6. I get 6 over 6 will give me 1 divided by 5. T to the 6. T cubed, increase by 1, you go to 4. Divide by 4. 4 divided by 4 again gives me 1. T to the 4th plus 2t plus some constant of integration. It's a new constant, so I try to make it look different. And so then we can set our condition. So at t equals 0, the initial angle is 1 radian. And so then when I put that into here, I get this as 1 radian is going to be equal to, when t is 0, this is 0, t is 0, that's 0, when t is 0, that's 0, and so this gives me my integration constant is just that 1, okay? And so we can go in and put that into here and rewrite theta as a function of time is going to be this, 1 divided by 5 t to the 6 minus 1 divided by 3 times t to the 4 plus 2t plus 1. And this is just in radians, I guess. And so there we go. So this was our angular position as a function of time. We could probably evaluate this and report the fraction to 2 decimal places. I didn't want to generate round off error until I was done, and then we could go back and, evaluate these, and it looks like we should only have 2 digits in all our values. So there's an integration, right?